Episode 147 of CppCast with guest Kevlin Henney, recorded April 23rd, 2018. This episode of CppCast is sponsored by PVS Studio, one of the most powerful static analyzers for your C, C++, and C# source code. With PVS Studio, you'll detect errors early, during the coding phase, and spend less time debugging difficult problems later. Try the demo version today at viva64.com/PVS Studio. And by JetBrains, maker of intelligent development tools to simplify your challenging tasks and automate the routine ones. JetBrains is offering a 25% discount for an individual license on the C++ tool of your choice, CLion, ReSharper C++, or AppCode. Use the coupon code JetBrains for CppCast during checkout at jetbrains.com. In this episode, we talk about Microsoft Make Code and web development with Witty. Then we talk to Kevlin Henney. Kevlin talks to us about C++ patterns and things every programmer should know. Welcome to episode 147 of CppCast, the only podcast for C++ developers by C++ developers. I'm your host, Rob Irving, joined by my co-host, Jason Turner. Jason, how you doing today?
Doing pretty good, Rob. How are you doing?
Doing okay. Don't really have much news to share today. I'm at home because my daughter is sick, unfortunately, but she should be fine tomorrow.
That's unfortunate and good, I guess, if she should be fine by tomorrow. And I'm back home, and I've got 2 weeks to work on my presentation for C++ now, so I'm feeling pretty good.
Just the one presentation this year, though, right?
Yep, one presentation, and looking forward to it. Need to start putting pen to paper. Just for the record, I do have lots of notes, and I've been thinking about this literally for months, so it's not like I'm starting completely from scratch here.
Okay.
But we've got 2 weeks left until C++ now, so if anyone has been waiting to the very last minute, you need to buy your ticket right now.
Yeah, right now. Okay, well, at the top of our episode, I'd like to read a piece of feedback. This week, we got an email from Peter in Serbia saying, "Great podcast. Started listening to you guys near the end of last year, and I always look forward to a new episode. There is a new lib in Boost 1.67 contract. Anyways, I was interested in seeing if you could bring someone more familiar with it, maybe its author, so we could hear more about it. That is, so you could ask all the questions for us, as you always do." Yes, we briefly mentioned the Boost 167 update last week and the new contract library, as well as higher order functions, I believe is the other one. But yeah, it'd be great to have the author of contract on, so I'll have to look up who that is and try to get them on the show.
Yeah, that could be fun for sure.
Yeah. Well, we always love to hear your thoughts about the show as well. You can always reach out to us on Facebook, Twitter, or email us at feedback@cppcast.com. And don't forget to leave us a review on iTunes. Joining us today is Kevlin Henney. Kevlin is an independent consultant, speaker, writer, and trainer. His development interests are in patterns, programming, practices, and process. He has been a columnist for a number of magazines and sites, including C++ Report and C++ Users Journal, and has been on far too many committees, including the BSI C++ panel and the ISO C++ Standards Committee. He is co-author of a pattern language for distributed computing and on patterns and pattern languages, 2 volumes in the pattern-oriented software architecture series. He's also editor of 97 Things Every Programmer Should Know and the forthcoming 97 Things Every Java Programmer Should Know. He lives in Bristol and online. Kevlin, welcome to the show.
Hi, glad to be here.
It's living in Bristol puts you really close to ACCU, huh?
25 minutes walk, to be precise.
25 minutes walk. Wow.
Yeah. So the ACCU conference was last week. The week before, sorry. And that is one of the curious luxuries of having it in your hometown, being able to walk in and not having to find a parking space or any nonsense like that.
Is it safe to assume you did go this year then?
Oh, yes, absolutely. Yeah.
Okay. Did you present anything?
Yes, I presented a session on procedural programming, which is part of a long-standing area of interest to present people with a very counterintuitive view, surprise people, go back and say, okay, what was procedural programming really about? What do you think you know about procedural programming? Because normally people use the phrase procedural to mean bad. It's a shorthand for saying bad. When somebody says our code is procedural, they don't mean it's great. So I wanted to actually go back and look at 1960s, 1970s. What were people actually saying? What were people actually doing? What was perceived as the leading edge of procedural programming? And surprise a few people with some of the things. So that was fun.
That sounds actually really interesting. Maybe we should dig into some more about that during the interview portion, Rob.
Absolutely, yeah. I mean, of distinct relevance here is the fact that I put some code up from Algol 68. I did some Algol 68 code, and I have the Algol 68 reference manual. The most important thing about that is if you've ever wondered where the keywords union, struct, int, void, all of those, it's Algol 68. That's where they all came from. So it's the most influential language nobody's ever used. Yeah.
Well, it's okay. Now, the interesting part from a historical perspective is, did you have an Algol 68 compiler that you could use?
Yes, I did. There is an Algol 68 implementation, an open source one, and it's let me think. I'm just trying. You can get. Yes, it's Algol 68W, A68, A68G, A68W. I'm just trying to get that right. It should be standard with. You can get it Cygwin, and you can get it on most Linux distributions as well. So Algol 68 Genie, that was what it's called. So yes, and it's a pretty conforming implementation as well. So this is yes, it's quite fun. So I was able to write some code, test some code, and present new Algol 68 code.
So some of those some of those languages from like the 60s and the 70s had like goofy things like requiring a specialized keyboard to be able to type in all the symbols. Was Algol in that world?
It's not quite. It had a sort of an idealized character set. You didn't have to do anything really too crazy. In fact, it assumed a subset because they didn't use any curly brackets whatsoever. So pretty much everything in Algol 68 was done with regular parentheses. Which led to some very interesting compiler disambiguation, but
I'm sure,
they assumed more of a subset, but there was a thing that was popular, an idea known as is it stropping? There's a particular keywording approach, so that if it didn't have proper keywords, so that sometimes people would mark those out. So a common implementation was that keywords would go in caps, and then all of your identifiers would be in lowercase, just to distinguish them. So it didn't have a proper concept of reserved words, which is why computer science journals got into the habit of doing keywords in bold. And then all the rest of the text was in non-bold writing, because actually that's how these things were presented. The bold thing means whatever you're doing locally, then follow that. Capitalize or put it in quotes or mark it out some other way.
Huh.
It's quite neat in that sense.
I must admit I'm slightly disappointed that you said everything was done with parentheses, because I was hoping that you were going to tell us this is where digraphs and trigraphs came from in C++.
No, disappointingly not. No, we're going to have to look to another source to blame for that one.
Okay.
There's a lot of really interesting stuff in there. And I've got some really nice little examples where I show radical innovations like the use of anonymous procedures, or as we would call them, lambdas. So 1968, and then finally 2011. So that was a slow progress there, I'd say.
And interesting timing. You waited until the 50th anniversary, effectively, to present this.
Yes, pretty much. I've been doing. It wasn't intentional, but last year I noticed I was doing more talks that were focused on the past, sometimes in language design, sometimes on the development practices that we have. And then I started noticing I was quoting from the 1968 software engineering, NATO software engineering conference report a few times, and I suddenly thought, well, we're coming up to the 50th anniversary, and then you look at that, you realize Algol 68, that was significant, massive influence. Bjarne used that in the mid to late 70s, and that and that it also influenced a number of other languages, C directly, and then indirectly again C++. And then we have other things like 1968 was Melvin Conway's Law. And it was the mother of all demos from Douglas Engelbart, so the mouse and all the rest of it.
Oh,
so,
right.
1968 was a pretty big deal in this case. So, yes, 50 years. I've kind of started making a bit of a point about that one. And 2001 A Space Odyssey was released, and that's one of my favourite films. So, it's just I had to include that one in the talk as well. So, yeah, there's a lot going on there.
Yeah. 50 years and nothing has changed.
That was disappointingly was my conclusion. Yeah.
Okay. That's unfortunate.
Yeah.
But we'll still talk more about procedural programming later, I think, if we have
Absolutely,
time.
Yeah.
Sure. So we have a couple news articles to talk about, Kevlin. Feel free to comment on any of these, and then we'll start talking more about C++ patterns and maybe some procedural programming, okay? Okay, so this first one is from the Visual C++ blog. And Spectre diagnostic added in Visual Studio 2017 version 15.7. And this is pretty cool. They have a new warning that can tell you, hey, this code, when compiled with the Spectre flag, is going to generate a mitigation. So if you want to avoid that mitigation, that could be potentially slowing down the processing speed, then this warning will show that to you.
Did you fully understand this example, Rob? Did you try to? I
I didn't look too deep into the example. Why? Is there something you noticed about it?
No. I noticed that everything is force in line, which just bothered me greatly. But besides that,
yes, that was interesting that you mentioned that bit, because I looked at it and it looks like the standard Spectre JavaScript example, because you got a branch before an array reference, and then that's going to force a preload. And I don't know if the force inline was really just a long-winded way of saying, please don't optimize this in any way, shape, or form. So I'm not sure what that was there for.
It'd be fascinating to recompile it without the force in line and see if you still get that diagnostic.
Yeah, because there's a sort of a suggestion that was what happened first. In other words, that we're seeing the after picture, that they tried to show it beforehand, and actually they didn't get the effect desired. I don't know, but it does raise an interesting question.
Now, Andrew wrote the article. Maybe he's listening to this episode and he can tell us later if that was required, instead of us, easily typing it in and doing our own homework on it.
Outsource it. No. It's crowdsourcing. It's community participation. That's what we're inviting.
Okay, but
Andrew Pardo, if you're listening, let us know the answer.
Now, Kevlin, so the part that was lost on me, and since I don't fully understand how these Spectre things work, you said the branch before the indexed operation, that's the critical part, lines 12 and 13 in the example?
Yeah.
Okay.
Because what we're looking at here is the fact that you can end up with a speculative load, as I understand it. You can end up with a speculative load, and this stuff's going to lie around, regardless of whether you took the branch or not. And and this potentially opens up an exploit. Curiously enough, actually, because this example is not designed to explore Spectre itself, just to outline the new warning feature. It is worth going and looking up the original JavaScript examples, because those make it a lot clearer what's going on, and really the mechanics is the same, but where you see that you've ended up with something being loaded that really shouldn't have been there. So I think that's really more a case of having to go and look at Spectre in detail rather than looking at this diagnostic to get the clue here. Okay.
And I must say, it bothers me just a little bit that we keep saying, let's go look back at the original JavaScript example to understand what the C++ is doing. Like,
yeah, there is a truth to that. There is a truth to that. I'm going to say that because that's the more dramatic one. But probably, and here's a thought for a future show. It might be worth getting a security expert who can walk you through this in C, because I mean that's the point. Is the sea level you can do it directly. It's just that most of the examples that you find that explain it are JavaScript. So it's not that my motivation is not really JavaScript. It's just that that's where all the examples are.
Sure,
therefore,
yes, yeah.
And therefore that's where the explanation is. It's also where the greater shock is when somebody says, "Hey, look, we're doing this in C or C++, and shocking security breach." It's just like, yeah, whatever. So so that it has more shock factor there. But I think walking through that with somebody who really understands the machine is probably worth a whole episode. To be honest,
we did some of that with Matt Godbolt.
Yeah.
Well, yeah. If anybody understands the machine, then and what's going on, it'll be him.
Okay. Next one we have, and this is actually a video up on YouTube, but it's another thing from Microsoft. This project they've been working on called Make Code. And it's, if you've seen anything with like Blockly, where, you're trying to get kids interested in coding and they can move blocks around on the screen in order to make a program, Microsoft kind of made their own version of this called Make Code, only instead of just making like a little in-app browser game with your code, you can actually put the code onto actual devices. They have relationships set up with like Adafruit and a couple other ones, and also with Minecraft. So that's the only one that's like a non-device thing. But you can, use Blockly, or I guess use TypeScript to make these programs. And this talk is actually talking about how they go from the Blockly or TypeScript and put it into C++ so that they can put it on these devices. Pretty interesting stuff.
Yeah, and there's a lot going on in this talk. Like, I feel like it could be an entire episode discussing it, really. But they have C++ functions that they can expose to their TypeScript, and then they have the TypeScript compiled to a machine code so that they can then load it on the, like, Arduinos and execute it. Like, some really interesting cross-language stuff going on.
Yeah.
Yeah, no, I was quite impressed with that. But funnily enough, the one question that I had was asked right at the end, which was Raspberry Pi support, which did seem that was missing. It's currently missing from it, and it's not something they've said they're going to pursue. And that seems a little strange, but perhaps that might be a perspective from where I'm sitting, in the sense that the Raspberry Pi is quite a big deal here. So that would be people's. There seems to be more of a preference for Raspberry Pi than Arduino in the UK, but that might just be a local perspective.
Well, and the Arduino, you're compiling to like 8-bit AVR with some like simple C interfaces and such. And if you want to support Raspberry Pi, then you have to compile effectively to a Linux ELF binary. Like, it's going to be an extra level of complexity for them, I would think.
Yeah, it's a different ecosystem, and it needs somebody else to put some proper effort into that. But it was interesting. The reason that question came to mind was more that they opened the talk by talking about kind of the origin of school-based projects in the UK. They talk about the BBC Micro in the 1980s, and that's the beginning of the talk. And funnily enough, the Raspberry Pi was conceived as a kind of like a 21st century response to exactly that. If you talk to the Raspberry Pi folk, that's exactly their memory. They grew up in that generation. So that's partly why I'm asking, or why people might ask them that if they make the reference to things like BBC Micro. In the UK, that triggers a certain thought pattern.
Right. And I think if I have my history right, arguably we wouldn't even have something like the Raspberry Pi, because we wouldn't have ARM if the BBC Micro had not been such a success and the funding had gone. And, the company ARM, what was the original name of the company? Acorn, didn't have the resources to invest in it.
Absolutely, yes. Yeah. There's an awful lot that stems from the BBC Micro and flows out from it. Yeah. Not just programmers. not just a generation of programmers here. Yeah, if you go around something like the ACCU conference, people of a certain age, myself included, had experience of that was a defining experience. But then you've also got the hardware, the culture, and everything that flows out from that.
Right.
Yeah. Okay, next thing. This was an introduction to web development in C++ with Witty 4. And Jason, we've never talked about Witty before on the show, as far as I can remember. But it's a web-based, application development framework. They actually reference Qt in the talk, how it's kind of going to be similar to Qt, but it's made for the web. But I don't think we've talked about this before, but they're on version 4 as of last September.
Interesting. No, I don't believe we've mentioned it at all, actually. I don't think I'd been familiar with this. The web toolkit.
I kind of wish we had this article last week when we had Jason Rice on the show, because we were talking about C++ web application development with him. I'm wondering if he's ever used this toolkit, but it looks pretty impressive. And if you go to their website, which is webtoolkit.eu, in the talk, he says that they make this website with Witty, and it's, a pretty nice looking website.
Yeah, that's pretty cool.
So I'm definitely interested in learning a little bit more about this one. It's another, thing that could be a whole episode that I'm going to see if we can contact the, someone from Witty if we can get them on the show.
Okay.
Have you heard of this one before, Kevlin?
No, I hadn't. So I watched this one. I was really interested because it's kind of well thought out, and the value proposition of Witty 4 is that it is C++ 11 friendly. Right. Although I noticed his compiler options were 14 rather than 11, so there's a sort of suggestion there that if that's a direction that they're probably thinking about. And it was interesting just looking at how. I was thinking, okay, what would this have looked like in older C++? And there are some, more extensive template usage. But I think what I'd be interested in for that is even more declarative approach. If they start embracing C++ 17 and beyond, being able to, they currently add nodes to the web page by just doing sort of an add operation and then passing appropriate constructor arguments through, having templated it, add a break, add a text box or whatever. And I'm wondering if using a more kind of uniform initializer style would be more natural. You can end up with a really declarative web page. Just really, you've got things there that are almost markup, types as markups, open curly brackets. You put stuff in there, and with being able to deduce templates through constructors now, then you end up with a really clean syntax. And so that sort of might be Witty 5, but as I was looking at it, I was quite excited by the possibility, just thinking syntactically how easy it would be to actually have the C++ looking exactly like web page structure and callbacks. Because it was quite obvious they've done, it looks good with the use of lambdas, but I think there's one more step, and I think that'd be quite interesting. So I was quite intrigued by that. So nice and lightweight. The use of large coding font to get simple examples is always convincing. It's just like, we can make the font this big and you can see everything, rather than, look, I fitted it on one slide and it's all in 4-point. It's just like, no, actually you fit it on one slide and it's readable. And it's just like, this is pretty cool. And I also like the way they've scoped this. They said, it's one-page apps. That's what we're good at. They're not trying to be everything, not trying to be all things to all people. It's just like, here's the problem we're going to solve, and we solve it. So and I thought, more impressively from another point of view, that I'm talking very much about the C++ experience here, but actually the way they'd structured it, just a proper generalized framework that if you disable JavaScript, you still get similar functionality. The idea that you can just change your browser setup and it will respond based on what is available. Whether it's WebSockets, you can drop that in or out, whether it was enable or disable JavaScript, and it still gives you a functioning web page. It just switches dynamically. I thought, that's pretty cool. It's some neat work going on behind the scenes there as well.
Yeah.
Wow. Yeah, that sounds really cool.
One other thing I just wanted to mention is I was looking I was curious about this when I was watching the talk, and I just found the answer. They do have both open source and commercial licensing, which I think is similar to the way Qt runs things, where if you're a company making apps, you can obviously pay for it, but if you want to make an open source website, you can use it for free. So that's pretty nice.
Yeah, I think Qt's slightly more liberal than that these days still, but depends on what exactly you're targeting. But still, that sounds pretty good.
Yeah. Okay, well, Kevlin, we've had a lot of listeners ask us to have someone on the show to talk about kind of common patterns and practices within C++, and it's not something that Jason and I, aren't really experts on. So it's really great to have you on the show, and maybe you can start off by talking about what some of the more common C++ patterns are that C++ developers should be aware of.
There's the problem is, I think. Let's rewind a little bit. Is that the problem is that with when anybody, and I noticed this a lot, perhaps more in C++ space than elsewhere, a lot of people, when they hear patterns, they immediately leap back in time. They get in their time machine, they go back to 1994 and the Gang of Four book, and as if that was the first and last word on it. And it's like, no, really, that was just 23 ideas that happened to be around in the early 90s, and we've kind of moved on quite a lot since then. Sometimes people use that as their kind of their total definition of what design patterns are. And also, from a C++ programmer's perspective, when people look at that book, they look at the patterns as if they were the code in that book. And we've got to remember what 1994 was like. That was pre-standard. In fact, it was pre-draft standard. So there is not a single remotely standard feature in there for anything. You're not even using there's no concept of strings, no containers, nothing. 1994 was the year that the STL was kind of adopted, but that would have been way too late for this book. So sometimes people look at that and they go, well, I'm not going to use these patterns because this is not how we do C++ anymore. And they kind of miss the idea that the pattern itself is somewhat deeper. This was an implementation code example, and actually it goes a lot deeper than that. It's the idea. So I think the first thing is to decouple that idea, get to the idea that a pattern is a way of solving a problem that happens to have trade-offs. And it has some kind of recurrence. Other people have found it useful, and you go, you know what, this is pretty good. So we can start, and there's always something about the context. And context is a very pattern-y term, but here we can say, if I'm working in C++, then one of the common context features is I probably have to manage my own memory. So therefore, what coding practices can I adopt that makes sense? Now, in this space, a lot of people say, "Oh, you're talking about idioms." Well, yes, there's a distinct overlap. These two terminology sets came from different sources, and part of the idea, and the problem is, I think with some idioms, the way that they're expressed is they don't offer you the full idea of the solution. What problem are we trying to solve? So resource acquisition. RAII as misnamed, because it's nothing to do with acquisition, it's release. There's nothing particularly special about the acquisition. So naming is hard, but that's your classic one that's your classic old school type of pattern. We still expect people to be using that, but commoditized at some level. But now the thing that people need to be looking more towards is the opening up of the more functional space. So once upon a time, people say, the command pattern, and they call anything that involved a callback and an object a command. And command pattern, it's like, well, there's a richer space around there. Once you've got lambdas, once you've got std function, all of this kind of stuff, there's this whole idea of a compositional mindset that's really different. So you start moving into genuinely the functional space, but the idea of what does that mean? If I've got language, if the language changes, then what does that mean? It means I can change how I do observers. I can change how I do notifications. I don't necessarily need class hierarchies to do stuff, where I can use compile time polymorphism, or I can use type erasure and get around that. So there's this idea of these old school patterns. Either they get displaced or they get expressed very, very differently, and there's a sort of a blurring of the boundaries. And then you've got commoditized stuff, your good old-fashioned iterators, which hopefully are going to turn into ranges very soon. But, the syntactic overhead of using that stuff in C++ 98 was a problem and actually held back probably a more widespread adoption of the styles that were associated with that. And indeed, I did a talk many years ago on patterns in the STL. I identified 25 patterns, probably half of which are now dead because I involved trait classes. There's a whole load of stuff now that we no longer need the same way. But it was what is the language that describes the STL? What are the patterns inside that? What patterns would you say? And people use terminology like half open, range, these kinds of things. These are little design ideas that all fit together to create a programming style. And that's kind of the way that I would think if you approach C++ 11, 14, 17, and 20. You start looking at that and say, well, what problems have gone away? And what new ways of expression have I got that tidy up the old problems and just make things more syntactically lighter? So patterns you want to be focusing on, not threading. There we go. I think that's almost a negative, an inversion of a pattern. The idea of not creating command objects that own their own thread. That used to be a really popular idea. The idea these days is that we favour a much more architectural view. The idea of keep your code small, single-threaded, and arrange something that coordinates that. So pipes and filters around it, talk through futures, use promises and futures, think about queuing. These are, we kind of talk about this in the pattern-oriented software architecture books. Keep away from raw threading. That's your low-level jump statement. You can build everything out of it, but work to a higher level. Continuations, all of these ideas are kind of where I think the modern C++ view is taking us from a compositional point of view. And there are, if you look around, you'll see that each of these patterns is documented somewhere: continuation, future, message queues, and so on. These all got written up at one time or another. So C++ now makes it easier to sort of embrace these.
And based on the intro, I'm guessing those all got written up in about 1968.
Oh, let me think. Yeah, some of those we had to wait. We had to wait as late as the 70s for. But yeah, by the time you reach the end of the 70s, most of those ideas had appeared in one form or another. So it takes a while for these things to filter through, doesn't it? But yeah.
You mentioned lots of different things like commands, objects, continuations. You mentioned specifically not avoiding manual thread management. Is there any particular thing that you think is worth digging into right now that you would like to talk about some more?
Well, I know you're going to ask me a question about reference counting.
Sure.
I wasn't going to dig into that necessarily, but actually, on the threading front, I think that's the kind of the overarching paradigm we should be embracing, is the idea of take a step back. The threads, just because you have threads doesn't mean you want to launch them. Just because you have mutexes doesn't mean you want them in your code. And so there is this idea that C++ is a language that embraces many styles, perhaps too many. Some days it feels like, particularly in legacy code. It embraces many styles, but there are some that make more sense than others. And there is this idea of composition, and I don't think historically C++ developers have embraced that enough. The idea of creating small parts that you can compose easily, that have minimal effect or zero side effect, and that's the same philosophy that drives continuations as drives the ideas of being able to pick stuff up from promises, or push stuff into promises, pick stuff up from futures. The idea that wherever you are, it should look simple and single-threaded. The fact that your whole program is massively concurrent that shouldn't worry. This little piece of code has a very single-threaded view of the world. It receives, it asks for things, it pushes things out, and it doesn't ever see a raw thread that it has to engage. And it's this small unit-like composition, I think, that is the architectural style that modern C++ can support much more effectively than it has done. So if I had to pick something, I'd say, yeah, it's all of these things. Getting people to be much more serious about immutability, which is easier, again, in more modern C++. So all of these things that just, take us in a direction, it's like small, simple parts that you can bind together. And that would be, that's where I think people need to be looking.
I want to interrupt the discussion for just a moment to bring you a word from our sponsors. Development of qualitative software is impossible without the use of static code analysis tools. These tools detect errors on the coding phase, i.e. at the very early stage. The earlier a bug is detected, the cheaper it is to correct it. One of the powerful static analyzers is PVS Studio. This tool detects errors and potential vulnerabilities in the source code of programs written in C, C++, and C#. It works on Windows, Linux, and macOS environments, and it conveniently and easily integrates into the Visual Studio IDE versions 2010 to 2017. You can easily check your CMake-based project or use compile monitoring if you use your own build system. The analysis can be conveniently integrated on the CI servers by using a command console. To reduce the analysis time, you can apply incremental analysis and IncrediBuild. The analyzer can identify potential vulnerabilities due to compliance of the PVS Studio diagnostics to classification of common weakness enumeration. To ensure continuous quality control of the source code, the analysis results can be uploaded to SonarQube. Try the demo version of PVS Studio and find errors in the code of your project. Since you did mention it, you wrote a paper on C++ reference accounting, and I usually hear it referred to as reference counting. What do you see as the difference between accounting and counting with references?
Well, part of that was, that was written, nearly 20 years ago, 18 years ago, 16 years ago. Not 1968. So what I did in that paper came out of a conversation I had with Jim Kevlin in 1999 over a few beers when he talked about reference counting. And he said, there's two ways. And I sat there in a pub in Oxford, and I thought about it for a moment. I said, no, there's 6 ways. And he said, no, there's 2 ways to reference count. I said, no, there's 6 ways, and one of them doesn't involve counting. So when I came to actually write this paper, which is nearly 50 pages long, I wanted to really break down the whole space and realize that not everything was actually counting. So, for example, you can have linked handles. Obviously, this is going to be a terrible idea in a multi-threaded environment, but there are cases where this makes sense. If I have smart pointers that form a two-way linked list, when I assign from another smart pointer, then I can say, well, hang on, I know you. I'm going to keep a hold of the other smart pointer. We form a chain. All of the smart pointers that know about an object. There's no direct count there, but if you were to measure the chain from one end to the other, you'd have the total number. The nice thing about this is it does allow you to do collective operations on all of the owners. It's a very edge case, but I have encountered a couple of cases that require it. So when I came to write the paper, it was a case of like, well, reference counting, technically 5 out of the 6 core patterns do qualify as that, but I thought actually there's play on words, reference accounting, because that's what we're trying to do. Just keep track of stuff. It's like double entry bookkeeping in some way. So yeah, that was the kind of approach of exploring where do you put the count? Do you put it inside the pointer inside the object, at a point in the middle, or somewhere else in a lookup table? And each one of these has different consequences and has different advantages.
Okay. Have C++ patterns changed or evolved in more modern times as the new versions of the standard have been coming out?
Yes, because some of the things that people, first of all, the emphasis. So when I wrote that, shared pointer was a boost thing, but nothing more. I mean, this was pre-TR1. So there wasn't even the kind of slightest hint of this being standard. But so therefore people were still rolling their own. Now, shared pointer actually fills a very important space. It captures the most common uses. But that paper is still, if you're interested in how would I go about implementing this, or what are the other cases that are not covered by it, then it shows you how to build those. But when I wrote it, it was more for the point of view of you want to build, you need to build a reference counting pointer from scratch. What kind of thing do you need to do? So that kind of manual approach, those patterns are still there, but we don't really worry about them as much. They're much more for the library implementers, not the users. They become commodified in one sense. So from one point of view, the center of gravity has shifted. Those patterns are still valid. It's just there's not as much need to know them because you can get them from the library. Likewise, implementing type erasure for a lot of people is not really something they need to worry about because they've got they've got function. All of these things do the right thing. So most of these mechanical things that you might need to know have kind of disappeared. RAII still, I can't see that ever going away as a low level pattern. Is still something that I think we'd like to think everybody knows, but actually it turns out it's a minority of people that know it. I'm going to guess pretty much everybody that listens to this show knows it, but that's not most C++ programmers. But for me, the balance has shifted with lambdas and auto, and std function, because that allows you to do a lot more decoupling through smaller functional units. It just gets rid of the whole ceremony of I need to create a new class, boilerplate that, put in loads of stuff, override something, do all of this just to get some kind of callback mechanics working. It's just like, nope, I've now just got a line of code, and that just makes it a lot easier to write certain things. That massively shifts the style, and you're not paying a penalty for it either. The compiler is on your side for most of this stuff. So I would say that the ability to use all callback-based patterns, anything that involved notification, pluggability, or anything like that, those suddenly become much more C++ friendly, and they finally move a lot of C++ code away from either being too C-like or being a little bit clunky with their objects, high ceremony classes with lots of boilerplate stuff in them.
Now, I'm curious, and I kind of now want to bring this back around to the procedural programming, if you don't mind. We've talked about
Absolutely.
The Gang of Four from the 1994, the classic design patterns book, and you talk about like some of these kind of patterns kind of being legacy things because we don't really need to we don't need to manually write that machinery anymore. So where's the historical context for this? Where is the advantage in still understanding how these work and relying on the abstractions that the language is currently giving us? And how did you, I'm assuming your talk on procedural programming relates to this.
It touches on a couple of those things, but let's have a look at that from another point of view. Why is it worth knowing some of these things? One, because not everybody works on a code base that is right up to the minute.
Mm-hmm. Right.
So a lot of systems have a legacy tail, which means that you can open up a file and it can start in the early 1990s, and you can kind of, by the time you reach the end of it, you've projected quarter of a century into the future. So in other words, you've got this massive span of version. So a lot of people are having to go into legacy code that was conceived at a very different time, and either they were handicapped by lack of availability of features in the compiler. So, for example, a lot of people sort of, our templates, not really sure about those, or we can't get consistent support for those. So, therefore, we're going to do all of our stuff using void pointers and casts and crossed fingers. Or we're going to just make everything virtual, and we're going to, everything's going to we're going to create a universal base class and this kind of stuff. So it turns out that sometimes the reason you need to understand this stuff is because your code will have this, regardless of what. It doesn't matter what you can do now. It's the code still has an opinion that is based on something from 20 years ago. And we have to remember that C++ 98, the clue might be in the year, but honestly, the rollout, the adoption of it was relatively gradual. We've been, in the last few years, people who've intentionally focused on C++11 have been able to track 14 and now 17 much more closely. But in 2005, you were still lucky. It was still lucky if you could find anybody using, saying, actually, we've got a C++ 98 project.
Wow.
So so there is that. So there is the historical perspective. History is still with us. The other perspective is if you are a library builder, you want to know about the mechanics. That makes sense. You need to know what it looks like under the hood. And then there's another one, which is to stop people using old patterns. You need to know about the old patterns to say don't do that, because actually some of them were superseded even at the time. There's things like decorator is really just not the best way to do a pipe and filtering approach and an adaptation approach. It's quite clumsy. Doesn't matter what programming language you're in. It's just actually not really the best way of doing it. You're much better off saying, I have a collection of things and I have something that is going to iterate through them and apply actions, much more like an interceptor. So in other words, it holds little functional objects and then applies something to them, iterating through them. Much better than saying, I'm going to pass something to an object, then it's going to do something and pass it on to the next one, and so on and so on. It's not just that gives you memory management nightmares in C++. It's just that it's actually it's quite a violation of the single responsibility principle, and it does involve a lot of choreography and coupling, whereas the alternatives tend to be a little more layered. So some of those, even back in the early 90s, were not considered to be great, but now it's a case of like, no, really, don't do this. So I think that there is this idea of revisit some of these things to know enough about them to say, actually, you don't want to do that. There's three reasons, but that shouldn't mean that everybody spends all of their time looking at the old stuff, because this whole idea of being able to look at the modern, more compositional approach, I think, is where people should be devoting most of their energy.
Makes sense. Could you tell us a little bit about the book you wrote, the 97 Things Every Programmer Should Know?
Well, I mean, strictly speaking, I edited it rather than writing it, because I managed to get everybody else to do the work, which is a minor stroke of genius. That was a part of a series that O'Reilly had at the time, 97 Things. The idea was, the whole series started off with 97 things every software architect should know. Then there was 97 things every project manager should know. And I proposed 97 things every programmer should know. And motivation for that was, from a personal point of view, was simply that I think it's easy. You can get 97 things out of any programmer. Just take them to the bar or whatever and apply them with the appropriate fluids, and you will get 97 things out of. That's not a problem. What's more interesting is the fact that no two people think the same way. If you poll a whole group of people, they will give you ideas you never even thought about. They will say it in ways you'd never thought about, and they will emphasize things that they personally have found important, and you go, yeah, you'd nod your head, but you probably wouldn't have picked it. So it was just one of those things. What is it that would really help people? Not so much, give them a complete education, but just sort of say, here's a bunch of pointers, lots of different points of view, get a whole load of people, and ultimately we had 73 contributors to that book. They're not going to have the same point of view. And if you're going to be a software developer, you need to have a broad base, and you want to have a kind of suggestion from different people. You don't want to be just made in one person's image, so to speak. You want to get as many ideas as possible. And so we had some really great and very different suggestions and proposals from that. So that was the motivation for that. A book that would actually be kind of fun, a scope for education. In other words, you can use this over lunch. You can say, okay, we're going to have you can have a reading group at work, and people can go through one or two items a week. Simple as that, because each item is 2 pages. It's relatively non-threatening. It's not the whole topic that it covers, but it's an eye-opener, or it raises questions, and it points in direction. I've actually got things in the book that contradict each other. So some people have gone like, "Oh my goodness, you know, shoddy editorial work." It's like, no, actually that's intentional, because not everything has one simple answer. I'm hopefully causing you to think, you know, here's 2 sides of the story. Where does the truth for this company or this team lie? And it gets you talking about things. So there's that. And a suggestion from a colleague was you can use it for book bombing. You know, you can, in that sense of, you know, your colleague is doing something that you've disagreed with, and then you walk by and, you know, you leave a post-it in the appropriate page. You know, you just say, look, see, somebody else said it's in this book. It must be the truth. Yeah. So it was that, and so we covered a variety of things. Some of them low level, some of them team based. So that was the motivation, to just sort of take a slice through something that is really quite large, which is the development space, and just say we're going to sample it and see what different people say.
And this is a language agnostic book?
It is. That one is language agnostic, and therefore from that point of view managed to get, you know, I got folks from Java space, the Ruby space, C++, sort of Unix folk, Windows folk. Hell, it's probably even I think I've got VI and Emacs mentioned by different people at different pages. You know, so, you know, very, very broad church. You know, it's very inclusive.
Is there any standouts from there that you would like to mention? Any of your favorite points?
Well, speaking as the editor, I'm not supposed to have favorites.
Oh, yes, right. All 97 of them are your favorite.
All 97 of them are my favorite. Okay, yeah, but I'm actually going to pick on a couple. I might as well. One of them I really quite like is A Message to the Future by Linda Rising. And it's a lovely way of putting this idea of, like, how should I think about writing my program? And she relates a tale. She's very much a storytelling approach, but this idea of, you know, you have a developer says, look, I've just done this in the cleverest way that I possibly could. And then there's this idea of, like, well, hang on, you know, is that the best way to do it? Is it the cleverest way? You know, if your little brother can't understand it, you know, could your little brother understand it? No, he hasn't got this far in terms of his studies. It's like, well, okay. Well, how would he feel if he saw that code? You know, so there's this idea of, like, well, maybe you should communicate to him. Maybe you shouldn't do the smartest thing. Maybe you should do something that is simpler. Maybe the smartest thing made you feel satisfied at one point, but probably there's a simpler story trying to get out in the code. And there's that idea of it's the idea of something that I often try and emphasize to people, is that coding is an act of communication. You're not just talking to a machine, and you're not even just talking to yourself. There is this idea of, what am I really trying to say? You're trying to shuffle your thoughts around. How do I divide up the universe in a way that makes sense to me, and I'm offering somebody else a model. What is that model? So I really quite like that piece, because it is this idea of a message to the future is how do I communicate to somebody I've yet to meet, or to myself in the future. It's a very constructive and very well written piece. So that one, I'm going to pick on that one. Then something that I also strongly believe in, Russell Winder's piece, Know Well More Than Two Programming Languages. I think these days it's probably, the book was published 2010. And I think it's safer to assume people are a lot more polyglot now than they used to be. But but there is this notion still, as Russell says, know well more than two programming languages, because there is that idea of looking at these things from another point of view. You pick up sort of patterns in other programming languages by just seeing them. You go, well, hang on, I know how to do that. It's a different way of thinking. And it actually allows me, it's a problem-solving technique. These, other languages offer you different ways of looking at problems. It's not just a coding thing at the lowest level. It's a way of looking at the world. Every programming language is a way of looking at the world. You can formalize things. What are the formalisms available to you? And so once you have that, you have binocular vision. You're seeing things from more than one point of view. You see more of the whole. So I think that one for me is something I do quote that one quite a bit as well. So yeah. So I'll pick on those two without being overly overly favoriting things. But yeah.
Okay, Jason, was there anything else you wanted to ask?
Well, we should maybe just mention that you are currently editing another 97 Things book. Is that correct?
That is correct, yes. And obviously, because this is CppCast, it's a Java book, So,
Still.
Yeah, I got into talking with O'Reilly about doing another book, and we had this kind of question like, well, what should the emphasis be? And we were wondering either programming domain. So there's a lot of possibilities of how you slice this one. So you could say, oh, well, let's do something on web development, or let's do something on mobile, or you can do it in terms of programming paradigm, say let's do something on functional programming, or you could do something in terms of platform. So strictly speaking, the book is actually about the Java platform, but that's a mouthful of a title. It's about things that fit in the JVM and the JVM ecosystem, and therefore languages. So therefore, JavaScript is acceptable as a language. And I'm not entirely sure I want to be misquoted on that one. Kevlin Henney says JavaScript is acceptable as a language. No, I'm not entirely sure that's true. But it means there's. I'm expecting people to talk about the sort of the Java build system, the JVM itself. Where it occurs, so in other words, talking about web development, mobile development, language-specific stuff, whether we're talking Kotlin or Clojure or Java itself. So, and I discussed the options with that. We did talk about C++, we talked about a .NET space one, and O'Reilly felt that actually getting back into this, because the timing of the last book was just in time for a recession, it turns out. Well, or rather, it was just as the world was sort of going into the crunch, and publishing was undergoing a bit of a crunch as well. So that's why there's been this hiatus since basically 2010 on their book series. So they thought, okay, the Java space is probably one that they can rely on, and then actually we will see what happens after that. So that's what I'm looking at. And if any listeners find themselves as they got one foot in that camp, then this book it's looking for contributions, basically. So get in touch. There's there's nothing special from your point of view. If you want to contribute, you just have to be able to think of something. Oh, I've always wanted to tell somebody that, or this is a way of thinking about something, and 500 words, that's about it. So that's pretty much it.
Okay.
Well, if you ever do a 97 Things for C++, you'll have to let us know. Come back on the show to.
I will do, and I will come back, cap in hand, begging for contributions, because this is stuff. It's just like, send us your stuff. But yeah, so I'm hoping the Java one's going to be successful, because that could reawaken this. Because I think a lot of people have enjoyed. There's certainly people enjoyed contributing. To be honest, people do write stuff and contributing. Oh, this is quite fun, but also this book seems to have had quite a good life. It seems to be quite useful from an educational point of view. You can kind of say, read through this, ask questions. It's quite useful, and that kind of book, I think, that kind of book that gives you a cross section. And certainly I can imagine in the C++ space that would be really useful. In other words, we've got a lot of people who are new, who don't know the language, don't know its history, and then you've got people who've got like pyrotechnic techniques that you're not entirely sure that you can understand. And that's just the error messages, So there's this idea, there's a massive range of possibilities, and I think that there's a lot of people to be reached through such a project.
Yeah.
Okay.
Right.
Well, it's been great having you on the show today, Kevlin.
It's been an absolute pleasure.
Yeah, thanks for joining us.
Thanks so much for listening in as we chat about C++. I'd love to hear what you think of the podcast. Please let me know if we're discussing the stuff you're interested in. Or if you have a suggestion for a topic, I'd love to hear about that too. You can email all your thoughts to feedback@cppcast.com. I'd also appreciate if you like CppCast on Facebook and follow CppCast on Twitter. You can also follow me at Rob W. Irving and Jason at LeftKiss on Twitter. And of course, you can find all that info and the show notes on the podcast website at CppCast.com. Theme music for this episode is provided by podcastthemes.com. Website at CppCast.com. Theme music for this episode is provided by podcastthemes.com.